our session today. Next slide, please, Venki. So StatiCa, yes, originally developed to tackle complex tasks. This is how many people remember StatiCa, specifically model and analyze the complex connections, which nowadays StatiCa, thanks to StatiCa, is not the biggest issue. Please, next section. Because the time changes, the regulatory requirements changes, the data requirements changes. So we see that the design and analysis itself, this is not the major issue of the structural engineers, as it was in the past, specifically for the complex connections. But now what we hear from every angle, every company, the issue is in the data. More complex, a lot of people involved in the process, consultants, contractors, detailers, connection modelers, various places you need to visualize the data and ever presented change management. So that's why StatiCa puts so much pressure on the checkbot development that, by the way, Venki just finished summarizing. And this powerful combination of checkbot and the connection is nowadays a tool that can potentially be used on a standard connection as well, something what in the past would not be realistic because of its very powerful, complex UI, complex solver. So we set ourselves a task to check how much faster current StatiCa is or is not compared to additional traditional tools that are used on standard connections, and we listed them before. Just for the sake of this comparison, because we really needed to have a fair fight, we chose our connection, but if we would choose some other tool, in the principle, the comparison would be very similar. What we try to focus on during this comparison is the full workflow, so not just the design, not just the analysis part, but everything before, all the way up to potential correction on site. So thank you, please. Next slide. Yeah, and this is the major premise for the comparison. Before I launch the poll, please pay attention to what we're actually asking. Imagine this kind of mezzanine structure. You have the definition on the right-hand side, so 15 nodes, 15 members, 4 load combinations. And imagine that you need to do the full connection workflow. So you need to first, you probably have some reference, either in the FEA model or some other output. You need to group it, you need to load it, then you need to create the outputs for 1A, approving entity, authority, and B for your detailer or some other detailer. So I'm now launching the poll, and please share with us how long would it take this task to you. So sharing now, and just reminding that you can find the poll next to the chat panel, the same place where you could find it before. So it'll be very interesting to see the result, even considering that a lot of viewers mentioned that they already use StatiCa on standard connections. So it'll be funny / interesting. What I also have to mention here as a disclaimer in between of your votes, in any way are we trying to mock the other tools, or that we just choose one that we will focus on? Not at all. We wanted to have a fair fight, transparent as possible, ideally unbiased as much as it can be. The other tools that we're comparing, StatiCa tool, StatiCa, They definitely deserve to be appraised for what they did in the past for structural engineers since the 90s when they were developed in the first time. So the only reason for this comparison is to actually check how they stand up against the time and compare to idea Statica. So the votes are in. So majority of you, this task would take somewhere between 1 hour to 90 minutes. The second most frequent answer is even more time, up to 2 hours. And there is roughly 1/3 of you who would accomplish these tasks 60 minutes or less. So this is what we know, and thank you. Back to you, and share with us how did you take up this task, because it was primarily you who were comparing it.
Yes, thanks, Jan. Let me take over. And a quick overview of the structure, for which was used for the comparison of the workflows. We didn't actually not only compare the connection design part, but the entire workflow involved in the connection design process. So this is the structure used for it. We have analyzed this in SAP 2000, and the stats of the structure goes like this. The number of nodes and members are 15, and the profile section used cross section W824 for all beams and columns, and the grade A36. And number of load cases are 3: dead load, superimposed dead load, and live load, with 4 load combinations. Moving on, let us have an overview of the workflow comparison, what we did. So on the left side, we have the other workflows. On the right side, we have the StatiCa workflows. First, let's focus on the left side. And all the steps we have, all the steps involved in other workflows and StatiCa workflows, we have split into 5 steps as marked here clearly. So we will be talking about the steps in the next slides. Now, let's focus on the left side, which is other workflows, which involves the visual review of structure, and followed by the grouping process, where you will manually group the connections and assign a unique connection ID to each node, so that you know how many number of connections to be designed, how many beam to beam, so on, etc., which acts as an input for the design process, followed by the load cases, where you will extract the force information from the SAP model and filter it based on corresponding SAP IDs for that connection, and get the envelope cases. This is also will be acting as input for the design. Next, followed by the connection design itself. For this, we can use the Excel templates or MathCAD templates or RAM connections or so on, etc. But for our comparison, we have used RAM connections. Next comes up the documentation part, where we have to extract the report from each connection and merge them, make like a design submission report, so that we can get a quick approval, followed by the most important of all, like the design intent transfer, which are primarily done by sketches. The sketches contains information about the member sizes, offsets, edge distance, bolt information, weld information, so on, etc. And coming to the StatiCa workflows, we have initially the import from, you will integrate the checkboard with your global analysis model, SAP 2000 in this case, but it's not only limited to SAP 2000, it's limited to much more. And you will integrate it and get the whole structure into the checkboard. Once this is done, next step is the grouping process, where checkboard does the grouping automatically, identifying of similar connections or similar nodes based on typology and cross section, followed by the critical combination evaluation. Here we will not be considering envelope cases. The critical combinations out of all the load combinations will be considered, and the process is automated in checkboard, so there's no manual steps involved, followed by the design. In this, since in the second step, the checkboard auto groups, each group will have a reference design and followed by its child connections or dependent connections. So in that group, you will just design one reference connection, then the design operations will be automatically propagated to the rest of the connections in that particular group. So that's why design once and apply to the rest of the connections in the group, followed by the documentation, which is submission ready design preparation. So I just showed in my presentation earlier that the checkboard workflows has new report features which can export a submission ready document report binder. So you can that's how it is done in IDStatica checkboard, followed by the final step, which is design intent transfer. Here in IDStatica, you can export the information to transfer it to detailers or send it to reviewers by either IFC file export, which will export your all the connections as per the SAP coordinates so that you can superimpose to other BIM tools, because IFC is an universally accepted format. And the viewer link, uh, which is quick to generate and which has all the information about bill of materials uh, and all the information, 3D information, and also 3D visualization. So let's deep dive into the each step and how we came to a conclusion on this. So first step is grouping and marking. In the left side, we have other workflows. For this process, since this is not a complicated structure, it's a small structure, so we just took a screenshot and copied to the PDF file, and we started grouping like general nodes, and we started marking it like beam to beam connection one, base plate, beam to column flange, and beam to column web. And uh, finally, we have summarized the number of connections required for the node, which are 4 numbers. And the entire process took us 20 minutes. Coming to the IDStatica workflow, we have integrated with the SAP 2000 model, where we have just selected the members and got the entire structure into checkboard, and the auto grouping is already done. We just have to review the auto grouped sets and just name them as required, like beam to beam connection, beam to column flange, so on, etc. And this process is done in IDStatica, and it took us 4 minutes, 2 minutes for the checkboard to import the structure into the checkboard, and 2 minutes for review of auto design groups and renaming them into required names. And followed with the next step, second step, which is the load cases. For the other workflows, which is on the left side, we have extracted the SAP IDs first, because we have to filter among all the member forces. We have to filter the corresponding SAP IDs for that particular connection. So we have filtered the SAP IDs from SAP model. Then we have summarized for beam to beam connection. We need only M14 and M15. And finally, we have extracted the membrane forces from SAP model, and we have started filtering based on that particular SAP IDs, and we started enveloping the case like the maximum, minimum, and summarizing it. Like if it's 25.6 or something, then we will approx to 26 kilonewton, just rounding it off. And similarly, we have done for the rest of the connections, filtering the SAP ID, getting the envelopes, and summarizing it finally for the quick review, all the connections, 4 connections, 4 different load sets, and the process is done here. And it took us 20 minutes for this load extraction. Coming to the right side, IDStatica workflows, we do not have a video for this, because the process requires no time at all, because while you are importing your structure from your global model, all the load cases and the combinations are automatically imported along with the structure. And by default, this evaluate critical effects is switched on. Once this is on, among all the load combinations, only the load combinations which are very critical for the analysis were considered automatically. So there is no steps involved in this process. So it's an instantaneous result. And we didn't consider any time. So in IDStatica workflows, we considered 0 minutes. Going to the next step, which is the connection design. Here, I will play both the videos simultaneously so that you can quickly review and understand. In RAM connections, we started with the topology and we added the member properties, grades, and load cases, and we assign a template, and we have modified the plate thickness, offsets, bolt grades, bolt spacings, wells, so on, etc. And once passed, like we move to the next connection, second connection, same process. And coming to ID Statica, in a group, we'll have reference connection and the dependent connections. Once you assign design operations to the reference connection, all the templates which were there in the reference connection will be auto-propagated to the dependent connection. So you are checking every node in your structure, but for their corresponding load combinations. So the process is this, and in the ID Statica, it's the last group, and in RAM connections, I'm doing the beam to column flange connection where we are assigning the bolt sizes, stiffness, and so on, etc. If you watch the RAM connections, there you can see the web trying is failing, so we have to add a web doubler, not necessarily a web doubler. We can use case diagonal stiffener as well. Do remember that we will talk a bit more about it a bit later. And the final connection, the ID Statica workflow is completed while the RAM is doing its calculation, and we'll update the template, and it is done. So both of this process, coming to the RAM connections, it took us 20 minutes to complete the entire design for these 4 connections. Coming to ID Statica workflows, in the checkboard, it took us 18 minutes. So I just want to make a note here. We did not use any shortcuts in the ID Statica checkboard, but you might be already aware of a lot of shortcuts like using of correction library templates, or you don't have to start from scratch. You can use existing templates or parametric templates, or even API calls to model it, or even grasshopper links. So we did not use any of those methods. We used the basic operations to start from scratch, and we've done the models. So there are steps to reduce this time as well, but we just kept it the hard way. And moving on, the step 4 is the documentation, where we have to extract inputs and outputs from each connection in the RAM. And similarly, we'll do for the rest of the connections. Once we have all the reports extracted, then we have to combine them. We can use Adobe PDF or any other tool to combine the PDFs which we extracted from the design files and merge them. Once merged, we have to review once, because this is a manual process. We might miss pages here and there, which might create issues later on during approval. So a quick review and the process done. This process took us around 10 minutes. And coming to the checkboard, as explained before, you can extract a design submission ready report from checkboard within a few clicks. And the process is done. You can export a PDF. And this process took us around 2 minutes. And finally, the design intent transfer, which is in the other workflows, it is primarily done with the sketches, like preparation of information about the sketches and wall spacings and so on, etc. And this process varies from organization to organization. For example, an organization might choose to start from scratch in AutoCAD. Another organization might have already templates in their previous projects. So they just can copy the template and modify it as per their current connection and recheck them. Or since we are already doing in RAM connections, we can also export a DXF file, which has a draft copy of the detail. So the draft copy is not cannot be readily submitted to the approval. So we just have to take it and format the dimension properties as per the project requirements and annotate them, add the section marks or additional details or connection ID, and close the detail. Before closing the detail, we will also review that so that there are no uh, wrong transfer of data, so that we have to ensure that the design intent is transferred properly. So a final check of the detail to be done. So this process, we estimated around 7 to 8 minutes per detail. For 4 details, it's around 30 minutes. So, and we have summarized it accordingly for this other workflows. Coming to IdeaStatica workflows, we can extract an IFC file directly, which has all the nodes as per the SAP coordinates, so that you can quickly superimpose with other BIM models and check for any clashes and so on. You have your link where you have all the connections in the drop-down box, and you have all operations, bill of materials, so on, etc. And this process, like, it's just clicking a link. It's well, but we still consider 1 minute for ID Statica. And moving on, during this process, we found some observations. As we were discussing, like, I asked you to remember a point previously while we are doing in the step 3, which is we've added a doubler plate here to the column. Uh, and we did not add a doubler plate in IDStatica. Why that is? That's because in other workflows, what we're doing is we are considering the envelope load cases, which is a max of all the critical load combinations. So obviously we are uh, imposing more loads. So obviously the web is stressed out, and we have to stiffen it either by doubler or a diagonal stiffener. In this case, it's just doubler. However, in IdeaStatica, there is no requirement for a doubler, web doubler, because here we are not using the envelope case. Here we using the critical load combinations, which are automatically calculated by checkbot, and followed by the next observation, where the interaction of stresses at node are not considered in other workflows automatically, because we'll be considering isolated connections, like beam to column flange separately and beam to column web separately, and so on. So in capture of interaction of stresses in the column node are not done automatically. However, in IdeaStatica, you will be designing that as a node with all the members uh, there itself. So the interaction of forces or stresses coming from all the members into that node have been automatically taken care of, and that respective column will be checked for the interaction of stresses coming from all these members. And also, coming to the detailing perspective and project perspective, there is a high probability of node conflicts later on, because you will be doing isolated design, like beam to column flange separately and beam to column web separately. So when you combine them together in your 3D model or later on, then you might have little space for the bolt tightening. If missed, then it might cost you costly refabrication errors later on. However, in IdeaStatica, you can notice all such details earlier on, because you will be doing it for the node, not as an isolated case. So there will be very few or no conflicts at all, because you can view this before it happens. And going to the next slide, uh, the other observations we observed were the workflow in other workflows is fragmented. Like, you need uh, different sets of tools and transfer of information. Like, one step creates an output that to be extracted and transfer it as an input to the next step, and this process has to be done manually. And as you know, like, if there is a manual process involved, there are high chances of minor mistakes happening. I mean, that is common, and we can't complain about it. And coming to the IdeaStatica workflows, it is a single model of truth, one source of truth. You just integrate to global model and get your model into the checkbot. Then there, you don't have to add any data, like the input data, like the forces or topology or grades. Everything is there in the checkbot. From there, you'll continue down the line with the workflow. And engineers are tied to the admin work in other workflows, like binding documents and uh, small minor things like that. And in the checkboard, it automates that process, so you don't have to spend time on it. So that's all from my end. I would pass on to Jan.
Thank you. Thank you. Wonderful comparison. For those of you who didn't do the math on the go, here is the summary. So you can see time taken in each task, grouping, marking, etc. And if you remember what I mentioned at the very beginning, that the connection modeling and analysis is not actually the biggest issue anymore. This is the confirmation. You can see how much time is spent on the tasks along the way, grouping, marking, report preparation, data handovers, etc. The total of each workflow, you can see down below. To me, when I saw this for the first time, I was so surprised. I was really astonished how much the data have significant role in nowadays. Data management. Sorry, data management has a significant role in current structural projects. So from this comparison on this exact example, idea StatiCa 25 minutes, the other workflows 100%. So it takes idea StatiCa to 75% time saving if you choose this workflow. Okay, here's the comparison of each task. Yes, you might say I have a Start Pro, which is in the same family of Bentley. Yeah, that's if you do more power to you, you would save 20 minutes on load extraction, and that's of course great to save. You might say that you have some optimization on the sketches, so the transfer of design intent would not be 30 minutes, but will be roughly 50% of that. Still, in the end, idea StatiCa is somewhere between 50 to those 75% more faster, and we would not stop there, as Venki mentioned, because the connection design, the third step, can be significantly faster with the use of templates or parametric templates. But this is not where our comparison ends. This is where the official comparison ends, but we have one more, or actually two more things to it, because this is typically not what happens in real life. In real life, you as an engineer have to face one thing, and that's change management. So let's just imagine what would happen when you, in the middle of the process or at the end, which also happens very often, you receive a geometry and load change. So in the journal workflow, the bad news is that you have to start all over again. You only save very small amount of time on the design that is already done and you modify, and on the sketches. In idea StatiCa, majority of the data changes happens on the background and automatically, so you only need to modify the connection design. So here again, if you would be facing a change management issue, this is where the hidden productivity killer is. But this is also not where it all ends. This would end if we live in the perfect world, which we're not. From the feedback from you engineers, we know that roughly 10% of the connections have some kind of interference on site. It doesn't mean that you have to rework all 10% of them, but roughly 7% would be pretty much on point. So in this comparison, when we compared it, the one workflow is the traditional one without idea StatiCa. We're adding the comparison. What would happen when you don't have idea StatiCa and you're left only with the traditional tool, and your standard connection, splice connection, fin plate, whatever, suddenly changes into non-standard because of eccentrical load, because of opening. Suddenly, you need to figure out how to do that, and this is the real issue in the end, in case you face it and you confirm that this is happening. So if you don't have idea Statica, solving this typically using some spreadsheets, because traditional tools will not help you there, you need to spend days. In this example, we used 1 day as an estimation. It is an estimation. That's the reason why we don't cover it fully into the comparison. But this is a real life. So we're wrapping up. Please do bear with us a few more minutes. This is an example of a customer, Aris, based in India, who designed Aquaribia, a water park not far from here, Kiria City in Riyadh. This structure was not significantly large, 2,500 metric tons, but the amount of connections was, in fact, huge. It was a combination of standard and complex, and actually this study was done before our comparison, and what I like specifically is that the numbers here match exactly. So even though that this study was done before our comparison, the customer confirms that they saved 75% on standard connections of this very specific structure. Of course, they had also complex connections. Here is the example, standard connection, but along the way they had to make it complex.